Hello, Honors Physics class. Hey, this is Mr. McKee, and I wanted to do the last part of question of the day 5.2, which is definitely the trickiest part. But a quick recap of what we did in 5.2. So we've got a mass going around like so. It has a velocity of 36 RPM, right? So we're going to change that into meters per second. We go through this and we got 3 meters per second. We did that yesterday. So in the first question, we are right here at point A, and we know mg, or the force of gravity, is going down, but we also know the force of tension is going up. Okay, so just to recap, the sum of the forces towards the center is the tension minus mg, because it's working against us, equals mac, which is mv squared over r. Okay, we're going to switch this over. We get force of tension is equal to mv squared over r plus mg. We get 1.7 and 1.5. I think that was 1.47, but regardless, when we add that together, we're going to get 3.2 as opposed to 3.17. All right, so at B and D, notice here that the force of tension and the force of gravity are perpendicular. They're not working against each other, so we can ignore gravity, which means our answer is just the mv squared of r, which is 1.7. Now, obviously at the top, now gravity and the force of tension is going towards the center. Therefore, the force of tension doesn't need as much help. So when we solve for that, we're going to get mv squared over r minus mg, 1.7 minus 1.5. So the tension is a mere 0.2. All right, so this brings us to the tricky part. And the tricky part is here at point P. And I've enlarged that over here. Now, one of the tricky things is if you read it, it says point P is half of the radius up from the bottom. So if we go half of the radius up from the bottom over to P, right, that means the next part right there is half the radius. So we end up with a triangle like so, okay? And we can see that we are dealing with cosine, because we have this side, which is adjacent to the angle, and we have the hypotenuse. So now we're going to take inverse cosine of the adjacent, which is r over 2 divided by r, which is the inverse cosine of 1/2. You will probably recognize that as 60 degrees. And if we know that this angle is 60 degrees, okay, we are set up for the next part. Okay, so now when we draw our free body diagram on this point right here, we're going to have the force of tension towards the center as usual, but now our force of gravity, or mg, is going straight down here. All right, so remember, this is one of our axes, always towards the center, which means perpendicular to that would be tangent. All right, so we're going to have this component and this component of mg. And if we know that this is 60 degrees, okay, we know that this one is going to be mg cosine 60. Okay, so now when we do the sum of the forces towards the center, okay, we're going to have force of tension minus, because notice that this one is going away, mg cosine. We now know that the angle is 60. That equals to mv squared over r. Okay, so now force of tension is equal to mv squared over r plus mg cosine 60. All right, so we already knew from over here that this is 1.7, okay? And now if we know that the cosine of 60 is 0.5, okay? So then half of our 1.5 here would be 0.75. Okay, and when we add those together, we are going to get 2.45 newtons. Okay, so the force of tension at P, okay, is 2.45 newtons. All right, definitely tricky, but all you have to do is set up that free body diagram, figure out your x-axis and y-axis. Now remember, our x-axis is really just towards the center. All right, hopefully that answers all your questions. We will see you guys tomorrow.